So, this video is going to primarily be for people who have kind of a basic grasp on the general concepts of programming, but are kind of struggling to get over that initial hurdle that is kind of understanding one of programming's bigger kind of walls to entry, which is classes and objects. This video should be applicable outside of a Godot context too, but I'm going to primarily use Godot as our kind of testing bed for things. Something I haven't really seen videos do before is really show kind of what you shouldn't do and show some bad code that's kind of naive and demonstrates the value of classes and objects rather than just jumping into actually how to use them. So again, this video is going to assume that you have a basic understanding of variables, a little bit of basic conditional logic, and I'm going to assume that you kind of generally know how lists/arrays work. So let's get into things. So we're going to make a Pokemon clone, which I think is a pretty good example thing here. So here's what we're going to do. I'm going to not really use nodes too much. We're actually going to keep everything inside of one script for now, which is very counterintuitive to what you should be doing in Godot. But again, we're writing bad code here to prove a point. So, Godot Pokemon clone. So we're not really going to script any input. We're really going to do everything via output into the terminal here. Okay. So what we're going to start with is just trying to demonstrate the basic way that this kind of turn-based strategy game works. So the very first thing we're going to do is we're going to need to basically somehow represent our kind of Pokemon, right? So the first thing we're going to do, and again, this is bad code, we're going to just use variables, which is at this point what a novice programmer would probably know what to use. So we're going to have a Pokemon name. We're going to have a health value for them. We're going to have a, let's call it an attack value for them, and we're going to have a speed value for them as well. And I think that this will be enough to kind of generally get the point across here. We'll have a type as well, which will just be fire type for now. So yeah, here we go. We have our first Pokemon. Great. Okay, so now let's just kind of print the data about our first Pokemon. We'll print the name. We'll print the health. We'll print the attack. Print the speed, and we'll print the type. Wow, and if we run this program, we see that show up in the lovely terminal right here. Okay, so now you might be thinking, okay, well there's one Pokemon for our team, now we just need an enemy Pokemon. Now this right here is kind of the pickle that novice programmers who don't really fully understand classes and objects find themselves in, is they say, okay, well I have this first Pokemon and these 5 variables here, right? I should just make another set of variables for the next one, right? So we'll be like, okay, Pokemon name 2 equals, what will I call this? We'll just make it engines. It'll be Unreal Mon or something. Health is 7. Oh yeah, we already named. So here's the issue right off the bat. We have already something named health in our program. So we'll call it health 2. Okay, sure. Then when I have attack 2 is 5, our speed 2 equals 5, our type 2 equals 7. Or no, that would be water or something. Sure. Okay, so now let's print our next one. And let's move this down here. Print Pokemon. Now, if you are observant, you're going to notice that I'm doing kind of the cardinal sin of programming here. Which is repeating myself, which we really don't want to be doing. I don't really need to make a full video explaining why this is kind of what we would call like a code smell, kind of a stinky kind of thing you don't really want to be doing in a system. But to kind of spell it out, the reason that this is really bad in a system is every single time we want to make a new Pokemon, we have to write 5 new variables, and we have to kind of append at the end of the variable names a number to differentiate them from the existing variables, right? And you might be thinking, well, okay, well, what if we just like make a node for each? We're still going to have issues where, and technically if you make a node for each, you're actually making a class and object, which is the whole point of this video. We're still going to run into these issues where these things aren't really properly represented. So then if we were to try and write code around this, we're getting into this weird avenue of like, let's say we want like Pokemon 1 to attack, 2, your Pokemon to attack the other one. We have to kind of juggle between these variables, and the code is going to end up looking super duper messy. So while technically we have properly represented the data that these Pokemon are going to need in the program with these 5 variables each, primitive types aren't really going to do it when it comes to trying to represent stuff that actually requires more than one primitive type to properly encapsulate. So, for example, if we were writing a program and we really only needed to work with like the ages of people or some kind of single numeric value, that doesn't really justify making kind of a class or object for that thing unless it's going to get a lot of mileage, right? Whereas if we have something like a Pokemon, which has 5 separate fields that are needed to fully encapsulate the one thing, what we lack is abstraction. So I'm going to move over to drawing mode now, and what we're going to do is we're going to take a quick look at an example of what I mean when I talk about abstraction. So we'll come back to that code in a moment. Basically, I want you to imagine an ice cream cone really quick. So close your eyes, visualize ice cream cone. Done it? Cool, good. I bet it looks delicious. So I'm going to draw mine. So we have a lovely little sugar cone here. We have some delicious ice cream. I'm not going to color it, but sure, it's chocolate. With a sugar cone. So you may have imagined something similar to me when I said imagine an ice cream cone. However, someone also could have imagined this. Let's say we have one of those, I don't know what these are called actually, the like ones you see at CVS or whatever. And let's say theirs has 2 scoops. Greedy, greedy. So this is like it's not a waffle cone. I think it's a cake cone. I'm going to need a video explaining every kind of cone after this actually. I'll do that next. 2 scoops. And let's say they have like vanilla and then they have mint. So completely separate. They don't really, they look somewhat similar, but they're not the same thing when we imagine these 2 things. But they're both technically under this umbrella of ice cream cone. So what we've done here is what I'm trying to do is distinguish between an abstraction and an instance of an abstraction. So when I say ice cream cone, what I'm describing there is an abstraction. We kind of have these checklist things you have to do to kind of meet the conditions of being an ice cream cone and fully encapsulate what it is to be an ice cream cone. And that is not the same thing. Oop, that is not where I want to draw that. That is not the same thing as an actual instance of an ice cream cone, which is the actual ice cream cone kind of, physically represented somehow, right? This distinction, I think, helps a lot and can kind of generate those eureka moments when trying to understand the difference between a class and an object. So to bring it back into a programming context, when we're confronted with some kind of entity that needs to be described using multiple primitive types, it's a good use case for building a new layer of abstraction into your system via a class so that you can then make data objects that actually represent the thing you're trying to build rather than kind of Frankensteining separate variables together and then trying to keep them in context with each other to represent it. So let's take a look at how we would do that in the Pokemon example. Let's switch back over. Okay, so in the Pokemon example, and I'm going to do this completely again in one script. Actually, no, I'm going to do this in 2 to be clean. So I'm going to just comment all this code out. So what we're going to do here instead is, there's no Pokemon name, so we're going to comment that as well. I'm going to make a new script really quick. Typically what you want to do when you make classes is you kind of keep a class in a file. We're going to call this Pokemon. Rename that. Pokemon. Okay. We're going to have this extend ref counted for now, which is basically just making an object. I'll explain this maybe later, probably not. This is more of kind of a high-level concept video than an actual syntax video. Class name is going to be Pokemon. So, spoiler, Anytime you make a script in Godot, you're actually making a class. It might not look like it because you don't see all of the kind of boilerplate class yada yada code you would see from something like C#, but this is now a class. We are now defining a new abstraction, a new type to exist in our system that we can use. So the first thing we're going to have to do is actually define, well, what are the variables of this type, right? The very first one we're going to use is we're going to just bring in all of these values really quick. So the issue with just copying and pasting this code is that we have to kind of change how we approach writing code when we're in a class, because we're no longer writing code that's actually going to be instanced. We're writing code that's kind of template code, essentially, right? So if I'm in a class and I actually set these values to something, these are basically now the default values for if we weren't going to specify these. So if I were to make a Pokemon right now, an actual instance, remember, concept versus instance, right? If I were to actually make an instance of this Pokemon, we're going to see that it's only going to be able to have these values, right? I'll show that really quick. So we're going to make a new Pokemon variable up here. I'm actually going to delete this code because it's ugly and bad and getting in the way. So I'm going to make a var Pokemon, and then here, we'll call that Pokemon 1. Pokemon 1 equals Pokemon. I need to save that so that it shows up, .new. So what we're doing here is we're basically taking the name of the class. Again, this isn't going to be super syntax heavy. This is, again, more, you've probably seen this before in Godot. This is more meant to be very conceptual. We take the name of the class, we do .new on it, which is going to spawn an instance of that class, and then it's going to store in this Pokemon 1 variable. So if I were to print Pokemon 1, we would see here that is a ref counted object. Now, if I look in the debugger and I were to just throw a breakpoint here, we could actually take a look at this, and we can see that Pokemon 1 here has Godomon, health 10, attack 2, speed 1, type fire, which is our defaults here. Now, the annoying thing is, if I were to want to make another one of these, Pokemon 2, and we do this, and we were to print Pokemon 2, and I were to rerun this, we're going to see that we have Pokemon 1 and Pokemon 2, which annoyingly both have the same values here, right? So what you might be thinking is, okay, well, how do we actually, change those sub-values of that object? Well, this is where a lovely operator called the dot operator comes in. If you have any object, instance that is, you can dot, and then you can access the values that we declared here. Basically, what we've done is we've bundled all of these sub-values into one new type, right? So in the ice cream cone example, we would have something like the cone type, whether it's a waffle, cake, or sugar cone. We would have the number of scoops. We'd have the flavor, exactly, all those things. So in Godot and in other programming languages, you can do something called a constructor function. This is assuming you kind of generally understand functions as well. I want to do a more in-depth video on this too, but this is, again, meant to unstuck people who are kind of stuck on this conceptual wall here. So the constructor function is basically the function that gets called when we construct an instance of an object from a class. So in this context, which is Godot, that is literally new. Whenever you call new on a class, it's actually secretly calling the init function of that class. So if I were to throw a print statement here, said making a Pokemon, we would see that show up twice in the editor here. Making a Pokemon, because we made 2 of them. You can also specify any arguments you want in this init function, which makes it really, really powerful. So what we can actually do is we can say, we can get the name, we can get the health, we can get the attack, we can get the speed, we can get the type, all by just plugging them in very easily. Now I'm doing something a little ugly here. Don't ever call variable names H. It's very undescript. I'm doing this for the sake of this video to keep it simple. There's a technically smarter syntax for this where you name these the same as these, and then you use something called, actually, I'm just going to do it, Let's just do it. Let's do it the right way. I might as well show you the right way. So I don't want to get derailed by a discussion on scope here necessarily, but we're going to really quick run into an issue here. So I basically just want to be able to plug in a Pokemon name and plug it into this actual variable, right? This code is shared among each instance, but each instance has its own set of these variables that we've created. So in the ice cream cone example, technically every ice cream cone has a cone to itself, but those might all be completely different types of cones. Some might be sugar, some might be cake, some might be waffle cone, right? So when you build the ice cream cone, you want an easy way to just plug in all of the necessary data to build it. What we're going to run into here is if I try and say Pokemon name equals Pokemon name, this is really ambiguous because I'm not sure if we're talking about this variable or this variable. So novice programmers might be like, okay, well, I'll just call this like Pokemon name arg or something, but this is going to get really annoying. What we can do is we can actually differentiate between these variables, which are actually supposed to be per instance, and these argument variables, which are going to get chucked once the function's done, by just throwing self dot in front of it. Self refers to whatever object is kind of currently hosting this code at a given moment. Because every instance is going to share this code and read from the same class, basically what we're saying here is, hey, whoever's reading this code and using it, whichever ice cream cone is currently getting built, just plug yourself in here and say, hey, my Pokemon name is whatever gets plugged in here. This way we can keep the name of the arguments the same as the actual values they associate with without actually having to rename them, which is really nice. Self is a really important concept to understand too, because as we do more complicated code in our objects, we're going to use this quite a bit. What this allows us to do is self-reference in code, essentially, which is really, really nice. So now when we make these Pokemon, I actually can specify these. So I can make the name Godot here. The next value is health, which I can make 10. These are all just kind of numbers, so I'm just going to put something kind of random in. And the type is going to be fire. And that's too many. Oh, there we go. I had to save. And then we'll just kind of do roughly the same thing here and change it. So this will be Unrealmon, and then we're going to make that like 40 and 52 and whatever. This will be water. And now if we were to run this, we can see that each of these Pokemon have completely different values, which is awesome. And we've cleaned up the code quite a bit. And now if we were to want to go through this code and, have Pokemon 1 attack Pokemon 2, what we can do is we can just say like Pokemon 2 dot health minus equals Pokemon 1 dot attack. And we can actually write this code and deal with the abstractions rather than dealing with, the minutia of trying to grab one variable for one Pokemon, grab one variable for another. They just all are on the same playing field. They all have the same considerations and the same data. So yeah, what we can also do in here is we can actually build functions as well. So if I wanted to even get a step further, what I can do is I can make like an attack function, which takes a target Pokemon as an argument. And I can even, we'll throw a pass here really quick. I can even make a take damage function, which takes a certain amount of damage. And we're just going to say self.health minus equals damage. Here we're going to say Pokemon, we'll call this target actually. Target Pokemon dot take damage, self dot attack, right? And now what I can do is I don't even have to write this code out. I can basically just say, hey, Pokemon 2 attack, to save this again, saving is good, Pokemon 1. And if we were to throw a statement here, I'm just going to throw that down to do a break, we can see that we're actually going to have that health go down from 40. It's going to go down to, what is it going to go down to? Negative 42. That makes sense because this says 10 health and this says this says 52 attack, so we super killed that one. So hopefully this has kind of illuminated, generally speaking, how you should kind of conceptualize objects in a Godot context, and in a greater programming context as well. Now, this ties into nodes as well, because technically every node that we create is actually a class. Every node in Godot is an object that we're actually instantiating into this scene tree. You can kind of think of it this way, like if we were to look at, for example, I don't know, like Let's look at a very commonly used node like let's look at for example, an animated sprite 2D, right? There is literally a class, animated sprite 2D, that the Godot developers have written that you can actually extend. And that class represents the kind of just concept of an animated sprite 2D, which is different than you actually putting an animated sprite 2D node into your game. So class, abstract concept, kind of lives not necessarily in actual memory, quote unquote, but just kind of defines what this kind of reused entity is going to be, versus instance or object that's actually the thing in the system built being used properly. So hopefully this video in this kind of rant form is helpful to someone. If you want to see more videos like this, please just comment any subjects you want me to kind of discuss, and I'd be happy to do that. This video is already way too long though, so I will see you in the next one, hopefully. Peace.